Okay, so the last main section that we are going to take a look at in Unit 2 with Tools of Science is data tables and graphing. So data tables come first because we need a data table in order to generate our graphs. So data tables are important because they actually help us organize our data. If you think back to the Mystery Powder Lab or any other lab that we've done previously, when we've constructed our data tables, those have actually helped us to organize our data so that we could use them later to help us draw our conclusions. Now, with previous ones, I've helped you or provided you with those data tables. So now what we're going to do is we're going to learn how to actually create those so that if you need a new data table, you can actually make one yourself. So the first thing that we need to do when we construct a data table is identify that independent variable. So kind of going back to the scientific method. Remember, that is the one that I control as the experimenter. We also need to identify the dependent variable. So what are we looking to see that changes? We will then make a table that has a title and 2 columns. And I'm actually going to show you kind of an easy way to construct that title because you just can't slap any title onto your data table. The nice thing is that the title that we generate for our data table, we can also use for our graphs. Now the title that we make has to be done using our variables. And that's kind of the key. Like I said, we can't just use any title for our data table. We have to incorporate that independent and dependent variable. So let me get my pen working here and get a color that you can actually see. There we go. So how do we construct a title using the variables? Well, it's actually pretty simple. The easy way is to start with the words the effect of. Okay? And then I'm going to draw a blank and then use the word on and then another blank. Basically, when we create this title using the variables, we're looking at the effects of the independent variable on the dependent variable. So for instance, we could say the effect of water on the mystery powder. We could say the effect of pH on temperature, or something along those lines. So whatever I am changing here, and whatever I'm looking to see what is changing, the appearance of the mystery powder, the temperature, and so on, I would put there. Now, like I said, you can always shift this over and put this on your graph as well. So this dual possibility makes it very, very simple. And if you construct your title this way, you'll never get it marked wrong, which is kind of nice. Okay, so once we have that title, we have to create a heading for each of the columns. The first heading is going to contain the independent variable, including the unit that is used, if any. And the second one would be for the dependent variable, including a unit that is used, if any. So let's actually construct a data table in that blank space on your note packet, okay, using the example that's listed in your notes. You have collected data for an experiment that you measured the amount of dissolved oxygen at various temperatures. And then listed on the screen as well as on your paper, we have that data. So our job is to construct our data table. So if you take a look at the data that is contained there, if you think about what you can control as a scientist, I, as a scientist, can control the temperature. Okay, I can actually change the temperature of the water, for instance. What I can't control that we measured is the amount of dissolved oxygen. So using that information, I can actually generate my data table. So let me go over to this screen. So we draw our table. So we have the one space at the top, the big wide one is for our title, and then we have 1, 2, 3, 4, 5, 6 rows. If you need to pause here so that you can sketch this, that is fine. Now in the title row, we are going to put the title, just like we talked about, the effect of the independent on the dependent. So the effect of temperature on dissolved oxygen. Now we need to add in our column headers. So the independent variable goes there in the first one, and the dependent variable goes there in the second. Notice that I have included the units after each label, and what that helps is I don't have to then put the units as I go down in the data table. All I have to do is fill in the data itself. Now, data tables are also good to help organize the data in such a way that it actually helps us. So in this case, we are actually going to organize it so that our temperature increases as we go down. So that means our smallest temperature should go first, and then our largest temperature should go at the bottom. So looking at our smallest temperature, if you look at our temperatures in our data, the smallest temperature there should be 15 degrees Celsius. And then we also fill in its dissolved oxygen amount that corresponds to that, which is 280 parts per million. We will then go ahead and continue that on down, okay, with the rest of the data. So there, constructing a data table is really not that difficult to do. You just have to follow a few simple rules. Now, using our data from our data table, we often can construct graphs. And constructing a good data table actually helps us a lot when it comes to making a graph. Okay, so let's take a look at how we make and interpret our graphs. All right, so in that space where it says basic setup, you want to kind of draw these axes. So you're drawing a typical graph set of axes with the y-axis being vertical and the x-axis being horizontal. The independent variable amounts go on that x-axis. Okay, and our dependent variable numbers go on the y-axis always. And so that's where setting up a data table correctly actually can help you, because if I set up my data table correctly, then I shouldn't have any problem figuring out what the independent and dependent variables are, and I can construct my graph very, very easily. Now, one of the toughest things to do with a graph is actually constructing the scale. All right, so when you construct your scale, try to start the numbers at 0, just like you would in math. The one thing though in science is it doesn't have to. Now, I usually get a question at this point in time about the break. And you guys know, I think, what I'm talking about here. You know, that little break that everybody likes to put in? And that's fine. I guess my suggestion would be if you're starting at 0 here and you put the break and put your first number here at 1,000, what might be smarter to do is instead of doing that break, just start your graph right here at 1,000. Because a lot of times what I see happen is people start here and they do a break, and that's fine. But then they go 1,000, and then they go 2,000, and they realize that they're not going to make the end value. And what happens is, let's say I have to go up to 10,000. Well, if I keep going by 1,000, then that's a problem. So they end up putting another break in here and putting 10,000. And you can't do that. Okay, that's a big no-no. Okay, I can't do that in the middle of my scale. I have to make it fit. Okay. Make sure you keep the numbers on the axis evenly spaced and at even increments. So you know what graph paper looks like. That's another big thing with me. You have to make graphs on graph paper. You cannot kind of jury rig your own graph paper using notebook paper. I have graph paper available up at the front of the room, or if it's like something on a test or you know, anything that where I know you're going to be constructing graphs, sometimes I will actually provide you with a grid space to do that. So what does this mean? Evenly spaced and in even increments. Well, you can see here, oops, nope, 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 sorry. You can see here that these tick marks are evenly spaced, okay? Now, you know, that could be, let's say, 4 squares. Let's pretend that there's like a grid here, okay? So each one of these is 4 squares apart. That's evenly spaced. So you make your tick marks. You do not have to label every single square, okay? That gets too crowded for a lot of people, all right? Now, even increments is one that students tend to mess up. Let's say I'm given some data, and on the x-axis I have data that includes these numbers: 1, 4, 10, 17, and 27, okay? What a lot of students would do is they would go 1, 4, 10, 17, and 27. And this is where the even increments come in. The value from here to here is 3, but the value from here to here is 6. Now this is the same distance. It's still 4 squares. 1, 2, 3, 4, 1, 2, 3, and 4. Okay? Basically that means the value of each of those squares is different. And then I change it again here to make it 7. And then I change it again here to make it 10. You can't do that, okay? What you want to do, if I've got to go from, let's say, 1 to 27, try to pick some whole numbers. Maybe I make it 6, so I go 0, 6, 12, maybe not even that. Let's try it this way. 6, 12, 18, 24, and 30. Now that probably won't work either, but you get the idea. The space in between each of these, or the value in between each of these, is 6, and it doesn't change. In my case, 6 doesn't work, so because that won't let me plot the 1 and the 4. So I would actually have to go to something different. Maybe I want to go by tens, 0, 10, 20, and 30. That would work. That may mean that I have some dots that are kind of out in space. And that's okay. I'm allowed to do that. Okay, but don't make the mistake about those even increments. All right, we've talked about this before. Your graphs have to have a title. Just steal the title, as long as it's a good one, from your data table. And what you need to make sure you do is that you only connect the points of data. Don't add other lines. So if you have your graph, let me draw a little sketch here. If you have your graph with your data points, okay, except for one lab that we are working with, I'm just making these a little bigger, we're going to play dot to dot. So you use a straight edge and you connect your dots, and that's it. You do not connect it to the origin, that's a big no-no, and you don't extend it beyond, because we don't have data out in that area to know that that's what's going to happen. All right. So those are kind of the basics here for graphs and for data tables. Now when we interpret graphs, we use some specific terms. Now I know you don't necessarily have room to put this on there, so you may want to grab a sheet of paper or find a place somewhere to jot these. When we talk about graphs, we often sometimes will talk about slope. And I know you've been working with slope in math. Slope is the change in y values divided by the change in x values. Basically, it tells me how steep that line is. When we talk about something that is an inverse proportion, it means as the value of x goes up, the value of y goes down. So let me show you a graph that has an inverse proportion. Okay, an inverse proportion, here's my axes, would look something like this. Okay, as x goes up, y goes down. A direct proportion means that as the value of x goes up, y goes up. So the slope is positive. So this would be something like this, or even just a straight line. Okay, this could also be a straight line down like that. All right, here the slope is positive, okay, because I would get that type of value, and here the slope is negative. Now, what we want to do is we actually want to move over to your graphing and data table practice packet. So if you need to pause here so that you can get those out, you can. And what we're going to do is we're actually going to go through an example here, kind of putting it all together. So we are going to work through the first problem here. It says, in one trial of an investigation, 50 milliliters of HCl, which is hydrochloric acid, of an unknown concentration is titrated with 0.10 molar sodium hydroxide. Now, I know you guys don't know what any of that stuff is, and it's okay. You don't need it for the problem. Okay, so you get that data, and you see the amount of data, or whatever data is there. Okay, you've got some volume of sodium hydroxide added, and you have the pH values. Okay, so step 1 says to organize the data by completing both columns of the data table provided so that the volume of NaOH increases from the top to the bottom of the table. Okay, now by looking at the data table, I already know a couple of things. I know that the volume of sodium hydroxide added in milliliters is my independent variable. Okay, so this is my independent variable, and then this one is my dependent variable, just by the organization of the data table. And that will actually help me with my graph. All right, so let's add in the values. It says that I need to make it increase from the top to the bottom. So that means that I need to put my smallest values up here at the top and my largest values down here at the bottom. So my smallest value is 10.0 milliliters, and I don't need the ml because it's in my column heading. When I add 10.0 milliliters, my pH is 1.6. There is no unit for pH. My next highest volume is 20, and its resulting pH is 2.2. Next we have 24, and the pH value there is 2.9. Next highest goes to 24.9, and my pH value jumps to 3.9. 25.1 is the next highest, and 10.1 is its pH. 26.0 comes next, and we have a pH of 11.8. And my last volume is 30, and its pH value, oops, I screwed that up. This is 11.1, sorry, and this one is 11.8. Looked at the wrong line. So that's what your data table should look like in this. Okay? Now, if you read number 2, we are going to use this information to make a graph. So it says, on the first grid provided, make an appropriate scale on each axis, give the graph a proper title, label each axis, plot the points, and connect the data points. Okay? So, what you need to do is you need to flip the page to that first small graph that looks like this. Okay? So you're going to look at this small grid here. Okay? Now, it says the first thing, it says to make an appropriate scale on each axis. So the first thing we need to do is make sure we put the right variable on the correct axis. Looking back at our data table, if you remember, we had our independent variable as the volume of sodium hydroxide, the volume of NaOH added, and the dependent variable was the pH. If you remember from our notes, the independent variable goes on the x-axis. So the volume of NaOH goes here, and then the pH goes here. Okay. Now, I need to make an appropriate scale. And this, quite honestly, is where kind of that art of making graphs comes into play. You may have to redo your scales a lot, just depending on how comfortable you are with doing it. I really highly recommend that you do graphs in pencil for this very reason. Now, I'm going to show you the way that I actually did this, but it doesn't mean that it's the only way. You can do it differently, and that's fine. All right. What you will see is I tend to make it so that my data gets very spread out as much as possible over the graph. And that actually helps me so that I can see what's happening more easily. If I crowd everything down into the one corner, then I really can't see a lot, and I'm not plotting things very accurately. Now, if I look at my x-axis data, I start with 10 milliliters, that's my lowest amount, and I end at 30. So I have, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 squares. Well, if I start, instead of starting at 0, if I start at 10.0 here, and I'm going to make this milliliters so that I don't have to write milliliters, and I put 30 here, and basically I make each square worth 2 milliliters. So I'd have 12, 14, 16, 18, tick mark, 20, 22, 24, 26, 28, 30. That actually works out pretty well. I've spread my data out, and I can plot all of my data points on there. Now, in terms of the pH, my lowest value here is 1.6. So I'm actually going to have this start at 1 just to keep it in nice round numbers. I'm going to make the value of each square worth 1. So I've got 1, 2, 3, 4, let's make this one 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now, down here, if you are not starting at 0, you need to tell me what you are starting at. If I left off either one of these, it is assumed that you are starting at 0. And that changes things here. If this 10 was not there, then instead of being each square worth 2, each square would be worth 4. So I would have 4, 8, 12, 4, 8, 12, 16, 20, and then 22, 24, 26, 28, 30. My scale would not be correct at that point. All right, I also have to give the graph a proper title. So let's go up here. So we have the effect of, now my independent is the volume of NaOH on my dependent variable, which is pH. That's a perfectly acceptable title. I used the variables, and it made life a lot easier on me. All right, I already labeled each axis, so we did that first just to make sure that we had everything set up. And the only thing I have left to do is to plot and connect the data points. So I'm going to plot these and actually put a circle around them. It just helps you guys with this to see them because I'm up on the big screen here. So my first data point is 10 milliliters and a pH of 1.6. So I go to the 10 milliliter line and I go up just a little bit beyond halfway and I plot a point. Then I go to the 20 and I go up just beyond the 2 and I plot a point and put a circle around it. Okay, 24, so the next line beyond 20 is 22, and then I go one more, which is 24, and I go up to 2.9, so 2.9, I'm going to be about here with a circle. All right, 24.9 is about halfway to the next square across, and I go up to 3.9, so 2, 3.9. Okay. 25.1, I'm not going to move that much over, but I am jumping way up here to 10.1. And then at 26, so 22, 24, 26, I'm jumping up to 11.1. And then at 30, I go to 11.8. Now, once I have my data points plotted, I can then connect them. Now, for me to connect mine up here, I can't use a ruler, but you guys should use a ruler or a straight edge to do so. So you're going to just play dot to dot.
Please excuse the interruption at this time.
Okay.
Students invited to attend the
There we
Friends
go.
of Rachel
So
Children's
we should have everything that we need for this.
Invited to attend the Friends of Rachel
Hold on.
Children's report to the auditorium. Thank you.
Well, at that point now, we've got everything that we need for the graph. So if you need to go back, I'm sorry, I did not plan on that. And you can actually continue working on the graphing and data table practice packet. What you can do is state the relationship between the volume of sodium hydroxide added and the pH of the resulting mixture. So if we take a look back at my graph here, there we go. Okay, my one line was a little off, sorry. If we take a look at this, basically as I increase my volume, I'm increasing my pH. Okay, so the more NaOH I'm adding, the higher the pH is. All right. So you have, on the back side of that page, you have another data table, and you will use the graph grid that is on the back side of the one that we just completed. And then after that, you have two more that you will actually be doing. All right. When I get back, I will have time to go over any questions or things that you may need to have answered regarding this.